Hi, my name is Crosby Ryder,
And my name is Bailey Thomas.
and this is our corn yield estimation video. So this is going to be the information needed to project your corn yield. So the number of ears per acre, so the total number of corn ears harvested in 1 acre, the average number of kernels per ear, so the average number of kernels on each ear of corn, and the kernel weight in pounds per bushel is typically 90,000 kernels of corn weight and 56 pounds or one bushel of corn. These are the calculation steps, or kind of just an overview. So step one would be to calculate the total kernels per acre, which is you do this by multiplying the number of ears by the average number of kernels per ear. Step two would be to calculate the bushels per acre. So divide the total number of kernels by the number of kernels per bushel to find the yield in bushels per acre.
And then for the data that we collected, first we had to find the row spacing. And so the rows of corn were 30 inches or 2.5 feet apart. And then using that measurement, we were able to determine that we needed to measure 17.4 feet down down the row to count the corn cobs. And so in our row for that sample, there were 26 ears of corn. And then you had to pick 3 random cobs and count those kernels. Our samples were as follows. Corn 1 had 528 kernels. Corn 2 had 624 kernels. And corn 3 also, ironically, had 624 kernels. So that gave us an average of 592 kernels per cob.
Hello, everyone. My name is Brock, and I'm here to talk to you about predicting profit and other things within corn. So, some reasons why we predict our harvest rates for our corn is for application, for fertilizer and irrigation frequency. We can predict potential issues based on our yield density. So, if we know how many ears of corn and tonnage per acre we have, we can predict certain issues that we might have, such as deficiencies within nitrogen and other key nutrients, potential pest damage, possible diseases, and whether or not our corn needs to be thinned. If it would be a very high density, we might have to go through and trim some of those off just to allow for airflow and better nutrient uptake as well as water uptake. And then we can also determine an estimate on tonnage per acre for the equipment needed. Some equipment needed would be during the harvest time. So we'd need, our personnel and staff workers. We need trucks and trailers to be able to move our product around. And then we also need harvesters and combines to actually go through the field to harvest that. And along with the equipment needed, we also need a buyer. So if we have a lot of corn per acre, we're going to have to figure out a buyer that is willing to buy all of that needs that much corn. Moving on to our next slide here. For crop production, marketability, and yield. So how we did this was through sampling fields. So we scaled down fields by doing 1/1000th of an acre. 1 acre is 43,560 square feet. So 1/1000th of that acre would be 43.56 square feet. So to measure our corn yield, we take the average quality of corn within that 43.56 foot radius. For us, we just round it up to 43.6 to make it a little bit easier on ourselves. We counted how many ears of corn were in there and then multiplied that by 1,000, which would give us how much corn per 1 acre. Now, if we had 40 acres, let's say, we'd multiply that final number again by 40, and then we know in total how much yield and marketability our product would have.
Hello, my name is Matthew Corona. I'm a plant soil science student here at Chico State, working towards a career in pest control and crop management and crop protection. So looking at the basis of our experiment here, looking at how we can project crop and specifically corn yield for marketability and yield. This is kind of a layout of our design. We have our furrows here, water would run. We have our corn spacing right here. It's important to know that we're doing it at a 1/1000th of an acre scale to get accurate, feasible sample size. So 43.6 is the 1/1000th. And then we're dividing that 43.6 by 2.5, which is the feet spacing between each row of planted corn, and then that gives us 17.5, which is going to be the length of our run. Looking at it, our 1/1000th kernel weight, 1 pound, and our corn bushel weight is 56 pounds. Looking at how we're actually gathering these numbers, it's important that when we're sampling corn, we measure our K times our L, and our K is going to be the perimeter of individual kernels, and our L is going to be the length of the row of corn. So K times L gives us our total kernels per that 1 ear. So if we do this by 3 ears and then divide those total kernels, add them all together and divide them by 3, which is the mean, getting our mean to get us our average kernels per ear of corn. And then multiplying that out, we're gonna scale this down to the 1/1000th of an acre, multiply that by our AKPE, which is average kernels per ear. So 19 ears collected in a 1/1000th acre area times 872 gives us 16,568 kernels. And that, reducing that down and dividing that by 1,000 gets us 16.6. That 1,000 represents our 1,000 kernel weight. So then we have that 1,000 kernel weight, 16.6 times 1 for the 1 pound. We have 16.6 pounds per 1/1000th of an acre. Multiply that by 1,000 to scale that up to the per acre size. Now we have 16,600 pounds per acre of corn kernels. Now we're dividing that by our bushel weight, which is 56, gives us 296 bushels per acre. And then you can scale that up by the amount of acres you have. And that's how we estimate bushels per acre of corn.
Thanks for watching. We hope you learned something from our video.